This is a CCEA M8 paper 1. This one's from November 2023. Question 1. 110110 is a binary number. 20 is a decimal number. Work out the total of the two numbers and give your answer as a binary number. So the way we set up our binary numbers, it's all to do then with powers of 2, and it kind of sets up backwards. So 2 to the power of 0 is 1, and then we have 2, 4, 8, 16, 32, and 64, and we need to put this in here, so it's going to be 1, 1, 0, 1, 1, 0. So it's 32 and 16, which is 48, 52, 54, so this number here is then 54. 54 plus 20 is 74, and writing 74 then as a binary number. Hopefully you can see, we'll just take it from here. So 64, we want one of those. We don't want a 32. We don't want a 16. We do want an 8. We don't want a 4. We do want a 2. And we want that. So 1, 0, 0, 1, 0, 1, 0. Question 2. Use a ruler and compass to construct the perpendicular from the point P to the line shown. So we need to set this up in such a way. So you want to get your compass. This is kind of hard to show on video. And I'm putting the pointy bit of the compass here. And then I'm setting up the pencil to mark off 2 points here. So there's 1. And there's another. So hopefully you can see those 2 things that I've marked off. You then want to put the pointy bit of the compass at one of those and do a big arc. Make sure your compass is over half the length of the line between there and there, and then also an arc between here and here, and that should bring you then to the right spot. So you can hopefully just about see that. My pen's not very clear, so the pencil's not very clear, and then we join up those 2 points, and that then is my perpendicular bisector. Question 3, 7, 10, 13, 16. Using the nth term, find the smallest number in the sequence above which is bigger than 1,000. So we need to find our nth term. So we have 7, 10, 13, and 16. And that's the first, second, third, and fourth term. And that's going up then in 3s. So that means my formula is 3n. We substitute the number 1 into this. 3 times 1 gives me 3, but I want 7. So it's 3n plus 4. It says using that, so we're going to go 3n plus 4 equals 1,000. Now you might want to make it kind of bigger than 1,000, but whatever way you want to do it. So in with 3n is 996, and then n is going to be then 332. I've just divided the 996 then by 3. And so that is the cutoff then for 1,000. So find the smallest term which is bigger than 1,000. So I think it should be the next one then, so 333. So if we let n equal to 333, let's check and see. 3 upon 333 plus 4, that gives me 999 plus 4, which is 1,003. So the answer we're looking for there. Using that term, find the smallest term in the sequence. So we're not looking for the sequence number, we're looking for the term, and our answer then is 1,003. Number 4. September 1st is on a Sunday. Nina has applied to do her driving test in September. No test dates are given on a Sunday. Nina is unable to do her test on Mondays or Fridays due to work. What is the probability that Nina is given a test date that she cannot do? So September the 1st then is on a Sunday. Nina has applied to do her driving test in September. No test dates are given on a Sunday. Nina is unable to do her test on Mondays or Fridays due to work. What's the probability Nina is given a test date she cannot do? So September the 1st then is a Sunday. So the Sundays are going to be the 1st, and then the 8th, and then the 15th, and then the 22nd, and then the 29th. Remember that we have 30 days here in September. Let me see. Of that then, so we have kind of 30 days. She is unable to do her test on Mondays or Fridays. And so we need to work out then how many of those there's going to be. So that's Sunday. So Monday is then going to be the 2nd and the 9th and the 16th and the 23rd and the 30th. And then Friday, Mondays is Tuesday, Wednesday, Thursday. You might have a greater way of working this out, but that's okay. 1st, 2nd, 3rd, 4th, 5th. So it's going to be the 6th, and then add 7 to that. So it's going to be 13. And then the 20th, and then the 27th. So we're not going to have one of those. So we have 9 of those. We have 4 of those. Sorry, we have 5 of those, and 4 of those, and 5 of those. So that's going to be 10. So it's going to be 14 of the days she cannot do. So no test dates are given on the Sunday. So we're down then to 25. So it's the 25 days here, and it's 9 out of 25. Is our answer there, because they're not given test dates in on the Sunday. So 9 of those out of the 25 left, because I'm taking the 5 off the 30 days in September. So 9 over 25 is our answer. A is 2.5 times 10 to the power of 8. B is 8 times 10 to the minus 2. C is 5 times 10 to the 4. Work out the value of A, B over C. Give your answer in standard form. So we got to go 2.5 times 10 to the power of 8 times by 8 times 10 to the power of minus 2 all over 5 times 10 to the power of 4. 2.5 times 8 is going to give me 20 times 10. So the 2.5 eighths, or 8 2.5s, gives me 20 times 10 to the power of 6. Now this isn't currently in standard form, but we can deal with this in a wee second. 5 times 10 to the power of 4. Divide this one, it's going to be 4 times 10 to the power of 2. Bit of a strange one here, because some people might want to change that into standard form. It's actually easier if you don't. And kind of leave that just as a 20. It just makes your life a little bit easier. It's only with a bit of practice you realise that. A and B are similar pentagons. The length of each side of the pentagon B is 3/4 of the corresponding side. What fraction of the area is shape B? So the scale factor for their lengths is 3/4. So the scale factor of their areas is going to be 3/4 squared, and if you square that, then you get 9 over 16. Question 7. Draw the reflection of the triangle in the line y equals minus x. So y equals minus x is one of those diagonal ones. I hope you realise that. And so we're going to draw a diagonal here. Excuse me while I kind of turn this around a bit so we can put it in. So there's my line y equals minus x. That's going to be my reflection line. And then I want to work out where I'm reflecting things. So I always count the kind of diagonal squares across. This is half a square. So here's going to be my new point here. Counting squares from this corner to here. That's 1 square, 2 squares, and then again 1, 2 going there, and then this one, this corner here is 1, 2 and a half, so it's a half, 1, 2, and those are the 3 points in that I need to join up. Question 8. M is directly proportional to D squared. When M is 36, D is 3. D is directly proportional to X. When D is 4, X is 2. Work out the value of M whenever X is 4. So I know that M is directly proportional to D squared. So M is K, D squared. whenever m is 36 is equal to then, so the d squared, so that's 3 squared, so it's going to be 9k. That gives me the value then of k is 4. So my equation connecting m and d is going to be 4d squared. For this one here, d is directly proportional to x, so d is proportional to x. D equals k x. When d is 4, x is 2. 4 equals 2k. In this scenario, we have k then is 2. I should maybe have picked a different letter than k there, maybe c or something like that, but that's okay. So we have d equals 2x. Work out the value of m whenever x is 4. So whenever x is 4, d is going to be 2 times 4, so d is going to be 8. And then whenever d is 8, m is 4d squared. So m is 4 times the 8 squared, which is going to be 64. So m then is going to be 256. Question 9. The point 5a lies on the circle x squared plus y squared equals 50. Find the possible values of a. Well, if 5a lies on it, we know the x coordinate is 5 and the y coordinate is a. So I'm going to substitute those in and we'll see where we go then from there. So hopefully you're happy enough. So 5 squared is going to be just 25 plus a squared is 50. That gives me then a squared is 25, and so a, hopefully we're good with that, is going to be plus or minus 5. So it's going to be 5 or minus 5. Find the equation of the tangent to the circle x squared plus y squared equals 50 at minus 1, 7. So our circle looks a bit like this. You don't need to draw this out, it just sort of helps me sort of see what we're doing here. So we have that, and the radius then is the square root of 50. And the point then minus 1, 7 is maybe up around here, and we're trying to find then the equation of this tangent. So how are we going to do that? We need a point on the line, we've got that, and we need the gradient. So the way we work out the gradient is we actually find the gradient of the radius, jump into there. So we're going to use our gradient formula to find this, and then the gradient of this is a negative reciprocal. So m is y2 minus y1 all over x2 minus x1. And by y2, I'm going to take this as coordinate 2 and then 0, 0 as coordinate 1. So I'm going to go 7 take away 0 all over minus 1 take away 0. And that gives me a gradient then of 7 over minus 1. So that's minus 7. And that means, therefore, my gradient of the tangent is going to be the negative reciprocal. So that's going to be a 7th. So I now know I'm going to substitute in the y equals mx plus c. Y equals a 7th x plus c. And to work out the c, I'm going to substitute the point x is minus 1 and y is 7 in. So I'm going to get 7 is a 7th times minus 1 plus c. And then this, a 7th times minus 1 is minus a 7th. And then if I add it onto this side, I get c is 7 and a 7th. So that's me pretty much. It's y equals a 7th x plus 7 and a 7th. And sometimes then we write it as top heavy. So that's then going to be 50 over 7. Question 10, change 0.527527 into a fraction. The way I do this is I'm going to let x equals 0.527527. I then, because there's 3 numbers repeating, 1, 2, 3, I times it by 1,000 because there's 3 zeros. So 1,000x then is 527. 527. I then subtract those two things. Subtracting this, I get 999x. Subtracting these all cancel, and I get 527. So that means my x then is 527 over 999. Part B, write down the value of 4 to the power of 3 over 2. So the 2 here means we find the square root, so that's going to give us 2, and then the 3 means we cube that 2. So if we cube that, we end up then with 8. You can do it the other way around if you wish. 4 cubed gives me 64, and then the square root gives you 8, and we end up then with the same answer. The length of the space diagonal of a cube is 9 centimeters. Find the length of the side of the cube, giving your answer in the form A root B. Well, the space diagonal is this bit here, going from here to here. It's like kind of opposite corners, and that kind of 3D Pythagoras theorem works for that. If we kind of have this as x, and this is x, and this is x, those are, because it's a cube, they're obviously kind of the same size. So we're going to have x squared plus x squared plus x squared is 81. That means I have 3 x squared is 81. It gives me x squared is 27, and then I want to find x, so x is going to be then the square root of 27, and we want it in this form here. So two numbers that multiply together to give 27 are 9 and 3, so it's going to be root 9 root 3. And the square root of 9, as we all know, is 3. So it's going to be 3 root 3, and that's the format that they wanted in. It's going to be 3 root 3. Question 12. A box contains 2 bronze medals, 6 silver medals, and 3 gold medals. 2 medals are taken at random from the box. What is the probability that they are both silver? So we have 8, 9, 10, 11 in the box, and we have 6 silver ones, so the probability to pick out a silver one first is 6 over 11. And then the next one, silver, there's 1 fewer in the box, so it's going to be 5, and there's 1 fewer in the box, so it's going to be 10. That gives me, well, you can cancel up some bits and pieces there. That's going to be 1 over 2, that's going to be 3, isn't it? And that's going to be 1, so I end up then with 3/11. Different types of metals, sorry. What's the probability that there are different types of metals? Well, there's an awful lot of options here. You could go tree diagram, but it's kind of messy, because you can have bronze, silver, gold, and then you're going to have bronze, silver, gold, bronze, silver, gold, bronze, silver, gold. And the ones that are different, then there's going to be 6 of them. So that'll be kind of gold, gold, silver, silver, and bronze, bronze. So I'm going to work out that probably they're the same, and then subtract it from 1. I'm already part of the way there, because I've worked out this one already for the silver ones. So for gold, I'm going to go for gold. And how many gold are there? There's 3, so it's going to be 3 over 11 times by 2 over 10, and that's going to be 6 over 110. What's the other one? We need bronze. Bronze, there's 2, so it's going to be 1 over 11, sorry, 2 over 11 times 1 over 10, that gives me 2 over 110, and this one there is 30 over 110, so that's gold, bronze, and then silver is 30 over 110, and we want to add those together, so it's 30 plus 2 plus 6, so it's the probability that they're the same as each other, and that's going to be 38, I think, over 110, and the probability that they're different is equal to 1 minus 38 over 110, and that gives me then, I think, 72 over 110. That divides down to give me as a 36 over 55, I think. And that's our final answer then for that. Question 13. A is this, B is this, C is this. Prove that only one of A, B and C is irrational. So what does that mean? We should be able to tidy these up and see that we end up with like whole numbers as opposed to square root numbers. That's kind of what we're looking for us to do. So let's go for the first one, which is A, and see what we have. So we have 7 minus root 5 upon 7 minus root 5, and that's going to be 49. Sorry, that's plus. Sorry. Then outer is plus 7 root 5. Inner is minus 7 root 5. And then last, minus root 5 times plus root 5, that gives me minus 5. They cancel, so it's 49 take away 5, and that gives me then 44, which is a rational number. Part B, 7 minus root 5 minus 7 plus root 5 all squared. So we tidy this up. It looks like FOIL, but it's not. 7 minus 7, that disappears. Minus root 5 is minus 2 root 5. And we're squaring that. So we square this and we square this. Root 5 squared is 5. This squared gives me 4. So my answer then to that is 20. So that one is rational as well. And then part C is 14 root 10 over 7 root 2. I'm going to change this to a root 2, so it's going to be 14 root 5 root 2 all over 7 root 2. So split my root 10 up into root 5 root 2. The 7 and 14 cancel, gives me 1 and 2. The root 2's cancel, and so I end up with 2 root 5 over 1, or of course then 2 root 5. Prove that only one of these is irrational, and sure enough, this is the one that's irrational. Question 14, so we're nearly there. So we have these three graphs here. A, B and C are three decimal numbers. The graphs of y equals a to the x, b to the x, c to the x are sketched above. One of a, b, c lies between 0.2 and 0.6. One of a, b, c lies between 0.8 and 1.2. One of a, b, c lies between 1.4 and 1.8. Which of a, b, c lies between 0.2 and 0.6? Well, 0.2 and 0.6 is the smallest one, so it's going to be kind of lower down here. So let me see if we can kind of set this up in such a way so you can see it. That has to be the smallest one here is this here, 0.2 to 0.6. It has to be. And then 0.8 to 1.2. And then 1.4 to 1.8 is then going to be this one here. If you do a number bigger than 1 to a power, then the number gets bigger. What do I mean by that? 2 to the power 4 is a bigger number. 3 to the power 4 is a bigger number, and so on. So if it has to be over 1. If it's over 1, then the thing's going to start to get bigger. That's why this one's going up. If it's a number smaller than 1, for example 0.8, whenever you put it to a power, the number gets smaller. 0.8 squared gives me 0.64. 0.8 cubed gives me 0.512. It gets smaller and smaller and smaller. That's how I know what each of those are. So which of A, B, C lies between 0.2 and 0.6? That's going to be C. Which lies between 0.8 and 1.2? That has to be B. And then D is a decimal which is between 2 and 2.4, so that's bigger than them all. Draw one possible sketch of y equals d to the x on the grid above. So because it's bigger than them all, we just go steeper. And that then will be our y equals d to the power of x. Quite an unusual question that, but if you understand, your kind of powers of numbers, then it should be okay.